Okay, in example 7, with the knowledge that you've understood in the previous video, for each of the following mappings, 1, state whether the mapping is one-to-one mapping, many-to-one mapping, or one-to-many. Part 2, state whether or not the mapping is a function. And the first one we are having 9, 4, and 1, and here we are having 3 minus 3, 2 minus 2, 1 minus 1. And you can see clearly this is talking about the square root of numbers, probably because the root of 4 is 2 and negative 2 also. So what we need, we need to show here, this is part A of example 7. What we need to show is state whether the mapping is one-to-one. This mapping, as you can see, every element in set A, if you consider this to be set A and this to be set B, every element in set A gets mapped to 2 elements in set B. So the mapping is one to many. This is one to many mapping. This is one to many mapping. But is it a function? That's the next question. No, it is not a function. The mapping is not a function. The reason why it is not a function is because we do not have a specific value of when x is 9. We cannot give a specific value. We have one to many, and therefore it is not a function because you could not write down a single value. For example, if we have f9, there is no single value, and therefore that is why the mapping is not a function. If we go to part B of the same, we have something that looks like this. We have a straight line whose equation is y is equals 2x minus 5. Of course, you can see for every value of x, we have a value. This is x1 giving us y1. This could be x2 giving us the value of y2. This could be x3 giving us y3. And you can see this is 1-to-1 mapping. This is 1-to-1 mapping. The second question is it a function? Yes, the mapping is a function. For a mapping to be a function, every input in the domain must map onto exactly one output in the range. And that is why this was not a function, because every input was having 2 outputs. But for this, every input is going to give us 1 output in the range. And therefore, yes, it's a function. Yes, it is a function. Let us look at part C. Part C is something to do with an asymptotic graph, whereby we have a graph that looks like y is equals to 1 over x. Obviously, we know it is asymptotic. And for every value of x, we have a specific value of y, as you can see. For every value of x, we have a specific value of y. For every value of x, we have a specific value of y. So yes, it is 1-to-1 mapping. 1-to-1 mapping. But is it a function? The question is it a function? My answer would be it is not a function. Reason being, when x is equals to 0, we do not have, there is no solution. It doesn't have a solution. There is no specific value of y when x is equals to 0. Something to do with along the y-axis, simply because the graph is itself asymptotic along the y-axis, and the mathematical name of the y-axis, of course, you know, it's x is equals to 0. So when x is equals to 0, there is no specific value of y. It would have been a function if we would have written it this way: y is equals to, let me just use this one. It would have been a function if you could write it: y is equals to a function, y is equals to 1 over x, where x is a real number and x is not equals to 0. That way, it would have been a very perfect function, because we know we don't expect any value of y when x is equals to 0. Let us talk about part D of the question. Part D is suggesting something like this. It is a quadratic graph. It's a quadratic graph. The graph of y is equals to x squared minus 1. What you can see here is when we have probably something to do with minus x, there is a value of y. When we have the same kind of x here, there is the same value of y. So is this a function? Before we go to answering the question whether it's a function, it is many to one, because several values of x give us one value of y, because this is y1. y1 is the solution of the function. It is the range when x is negative x, and it is still the range when x is positive x. So it is many, this is many to one mapping, many to one mapping. The question is it a function? Is it a function? And my answer and your answer would have been yes, it is a function, because for every value of x, it gives us one value of y. But there are different values of the domain that can give a value of y. So this is a function. Yes, it is a function. It is a function. It is many to one mapping, which is a function. If you read down there, watch out. Normally the domain is all the real numbers unless otherwise stated. And this is an example of that otherwise, which would have made part C a function. But because it is not stated, then this just this part makes part C not a function, because the otherwise is not stated. Okay.